My name is Markus. I've about 8 years ago, no, not 28, 8 years ago, um, yes, exactly. I was fed up with Xtext and started getting seriously interested in MPS, and um, essentially from that frustration is where the Amos MPS team kind of grew out of. And so I'm actually quite happy to see so many people who use this stuff here. Um, so I want to give you an overview of some of the things that the Amos team has done in the last years. I'll very briefly recap where we come from to give a little bit of context, and then I'll point out interesting, relatively new things. Most of them are open source, some are not. I'll point out when they're not. But the idea is that you kind of perhaps might want to use some of this stuff in your own projects. So it's almost like a chart of interesting things that we think we've done that other people can use. So it's not a visionary keynote. It's more like a here's some stuff. Yes, all right. So again, bit of history. Between 2010 and 2016, we built mbeddr, which you probably all know, which is this set of C extensions for embedded software development. And as part of that, we also started collecting reusable utilities in all shapes and forms. And we at some point called that the mbeddr.platform. And you guys probably used some of these in various projects. It contains the table notations, the diagram notation, rich text, which is what we call the unstructured text with embedded nodes, the math notation, and so on. It has utilities for custom project views and custom context actions. It has the grammar cells. I'll talk about those in a moment. If you don't use them, it's really a mistake. Where's Nico? He's supposed to be here. He left Amos in the meantime, but he was on the team and he built the interpreter framework, and there's supposed to be a talk of his. Right, so let's hope he shows up. Otherwise, we can show it too. Yeah, tooltips, file pickers, all kinds of things. It's all perfectly documented, not, right? So you might have to dig a little bit to find some of these things, or send an email, or ask on the Slack. But most of the stuff works pretty well. There is some early incubation stuff that doesn't work. We're in the process of throwing that out. Then between 2016 and 2017, we had this research project called IATS3 together with Fortis. mbeddr was, by the way, also with Fortis. And the goal was to build essentially an integrated systems engineering environment. We didn't quite get there. One reason why we didn't quite get there is because we had customer projects that gave us money to do work, so we kind of prioritized that over the research project. But a lot of interesting utilities came out of that as well. One of them, KernelF, which is a functional base language, which you can use at the core of DSLs. And because it's functional, it's a little bit more useful for this purpose than like MPS's base language. Well, unless you want to extend Java, of course. Talk about that. Oops, shouldn't step on this stuff. Talk about that as well. And then just to give you a few impressions of languages we've built over the last couple of years, mostly business DSLs, which we would define as languages which are not intended to be used by programmers, but rather by domain experts. We're in the process of trying to establish this term Fachlichkeit, also in the English language, because it doesn't like kindergarten, right, or Schadenfreude. Because Fachlichkeit, this word doesn't really quite exist in English. Business logic isn't the same, right? So anyway, we're trying to represent the Fachlichkeit that is independent of the actual implementation technology. Here is an example from the healthcare domain. I'll talk about that later a little bit more. There is math. This is a prototype we built that uses actuarial math from the insurance domain. This is a product we're working on with Fraunhofer that is used to analyze security properties of, well, technical systems, usually those with 4 wheels. This is, well, the beamer is a bit bright. You can't see the gray lines, but this is a a language that is used to define temporal rules for Fahrtenschreiber, driving log, the stuff in trucks that says you have to make a pause because it's illegal to continue to drive, you know, whatever the word is in English, I don't know. And you can see this kind of weird notation which our customer prototyped in Excel, of course. And then Sasha built a whole bunch of special purpose notations to get that into MPS. We've implemented a language for feature models to manage variability, systems modeling stuff. This is an example of a language that's used for specifying public benefits payments, or to implement the logic by which you compute how much, for example, Arbeitslosenversicherung, out of work, whatever the word is, insurance, yeah, you get the point. And you can see that this is a kind of mix between forms and languages. So this is just supposed to give you a bit of a broad overview of the kind of stuff we've built and of the notations MPS supports. You might know all of this already because you use it, but on the other hand, let's say I also know of companies who use MPS, but they use like 10% of it, especially in terms of possible notations. And so I thought it's a good idea to maybe point out the space that's feasible. And this is all built based on notational primitives that are part of the mbeddr platform, except that, because that's really a customer project specific language extension for the editor language to build that particular notation. It's also not reusable. It's too specific. All right, so let me point out a few particular things. First of all, grammar cells. I already mentioned if you don't use them, it's really a mistake. We are of the firm opinion that this should be in MPS, like directly. Maybe it will be one day. So what this does is, instead of using editor cells, the normal ones, and then manually implementing actions to make the editor work nice, you know, side transformations and stuff like that, you use special cells that we provide in grammar cells, and then all the actions are automatically generated. So this means that whenever you want to be able to have, you know, expression plus some other expression, and you know, inline infix operators automatically generated, it does expression reordering based on priorities, you know, reshuffle the tree so that multiplication binds more tightly than the plus. It supports inserting of parentheses around expressions anywhere. It has support for optional parts, for flags, for wrapper actions. It's really useful. And what it does is it allows you to build editors that behave nicely with almost zero effort. The not zero part is when they don't work as expected, and right. But I mean, there are some corner cases. The point is that they are, of course, heuristics driven, because strictly speaking, you can't, in the projectional editor, you can't completely deterministically emulate how a kind of fluid text editor would work. There are heuristics, and sometimes they don't work. It's unavoidable. But they work in a like 95% case, and it really makes a big difference. It gives you a consistent editor feel, and so since we've been using these things in projects, we have no more complaints from customers that the MPS editor sucks, which we had earlier, because they were just inconsistent. Sometimes you had right transformations, sometimes you didn't, and that's of course annoying. So doc language? You mean the mbeddr documentation language? I have no idea. Yeah, rich text is a bit, yeah, well, only the paragraph, the rest isn't. So yeah, but the rich text is a little bit different. Yes. So if you want to learn more about this, there is a paper that we wrote for SLE 2016 at that URL, which is also in the barcode or QR code. Not going to do a demo, don't have time. But if you take one thing from this session, use this stuff, seriously. And why should I care, right? You can do all the work manually. But the thing is, if you do it manually, your editor will be bad, your customers will complain, and MPS will get a bad reputation, which I don't want. So that's why I care. Okay, KernelF. F for functional, kernel because it's intended to be used in at the core of DSLs. It's a functional base language, so I was going to say it doesn't do anything with effects, but that's not quite true. There is a language extension that deals with effects in the same way as you would do it in Clojure, essentially. And yeah, we've been using this as the basis for several DSLs. So when we look at how we design languages, then we have identified essentially 3 patterns. One of these patterns is that we have expressions at the kind of core of the language. Then we have a domain-specific behavioral paradigm like state machines or rules or something like that. And then around that, we have domain-specific data structures like insurance contracts or, you know, Fahrtenschreiber rules. And so expressions are everywhere, and we didn't want to reinvent them all the time, and so that's where we built KernelF. It's also solver integrated, which means that, well, at least very soon, it's not quite completely done yet. There is a SMT solver backend which can prove properties or check correctness of certain aspects of the functional program. Like the simplest case is if you have a bunch of essentially switch case thingies, then you can check that these case expressions are overlap-free and complete. But there are many more interesting things. For example, if you have a function with pre and post conditions, it can verify that these kind of are consistent and that they will always hold and stuff like that. It's really interesting. It's also not so simple, which is why we're still working on this. Specifically, Bjorn in Hamburg is working on this. Anyway, cool stuff. So a few more details here. The design drivers for that language was, of course, simplicity, because we wanted to be able to use this with non-programmers. Extensibility, because it should be extended as part of DSLs. Embeddability, which also means that you have to be able to remove certain things. For example, the set of primitive types that KernelF comes with can be thrown out and replaced with other primitive types if your domain has different ones. That was an important thing that we also didn't realize quite from the beginning. Robustness, of course, and then IDE support, which is kind of obvious with MPS, so not really worth mentioning in this context. So it has primitive types, arithmetic operations, the usual stuff. But then the number types, for example, they do range tracking, right? So as part of the type system, you get errors if your number gets out of the specified range. It isn't a perfect implementation, because if it were, we needed a complete dependent type system, which is also something that is not quite so simple. But it does useful things in many cases. We have options, right, to deal with non-existing values or nulls. We handle errors through a temp type, so a function can return a string or some kind of error, right, or whatever the base type is, not just strings, of course. And we do effect tracking. So by definition, of course, a functional language has no effect. You can cache, you can evaluate, you know, lazily or cache the previous result because nothing ever changes, which, as somebody said, of course, only heats up the CPU, right? If you never change anything with no effect anywhere, then it's kind of pointless. But anyway, the language supports effect tracking, so at least the interpreter, for example, knows where it can cache and where it's not allowed to cache. Yeah, it has a few advanced features, for example, type tags and units. Well, there's a language called .units. I'm not 100% sure about the state. Ah, okay, I didn't know. Okay, great. Okay, perfect, great. It has the math notation, and of course, we have all these utilities, the usual table gimmicks, right? Which is interesting because there is a new OMG standard called Decision Model and Notation, which is a very fancy word for a functional base language plus decision tables. And so while this doesn't support exactly the standard, it's close enough to claim that it's kind of the same thing. Who does? Who? Yeah. Yeah, I mean, we were thinking about implementing the OMG standard, but and then say it's the standard. Yes, yeah, good point. But I'm not masochistic enough to participate in these meetings, so no way. Something went wrong? Ah, okay, all right. And then of course it has unit tests. Interestingly, we have a support for coverage analysis, so you can be sure that, for example, your interpreter is completely tested. Test generation with a debugger for it. So it's a quite complete set of stuff you might want to use for your own base language. Here's an example of the coverage analysis where we check that as part of your test cases, every language concept is used, and then how often is it used, and these numbers are a measure for the complexity of the syntax tree in which it's used. Like, if you only test your language constructs in trivial cases, then whatever random interactions, of course, might not show up. And so the higher you get these numbers, the more confident you can be that there aren't any unintended interactions of that particular language construct with others. Of course, it's heuristic-based. Again, it's not complete coverage. It's never a guarantee for any for the absence of errors, but yeah. And we also do coverage measurement for the interpreter. I probably should have said that KernelF ships with an interpreter that runs directly in MPS, so you can build simulators and tests and debuggers right in the IDE. And for that interpreter, there's also coverage measurement. So you can be sure that the implementation of the semantics of your language in the interpreter has been completely tested. All right, more stuff. Test generation with various strategies of generating test values. We've also recently, as it says here, experimental, implemented a data flow language on top of KernelF. So this is for the engineers among you. Well, I guess those that are here probably don't have that problem, but there are, of course, engineers, as we know, who think that adding two numbers with a box and two lines is easier than writing 4 plus 3. I don't happen to agree. It's quite funny. If you take this, there's an intention that says generate function from this thing, and it like and it's like 5 plus 7 times 2, and you have this picture, right? So, but for anyway, it's interesting for the graphical programmers. You can now do it, and there is so you can perhaps see that there are lines. So we've implemented a spreadsheet language, a generic Excel kind of thing, where you can, refer to other cells and stuff. And while we're always joking about how Excel sucks, right? And how DSLs are a better alternative to solve these kinds of problems. But what this thing is definitely useful for is to take people who already know Excel and slowly move them to a more structured way of doing things. I'll get back to that later, why we built that particular thing. This also showed the scalability limits of the table language, because if you have more than 20 by 20 cells, you can watch it repaint, okay? Which is why Sasha right now, it's probably why he isn't here. Actually, somebody has to work. He's implementing a more scalable implementation of the table language to solve that issue. And for various reasons, it is a little bit in conflict with how MPS renders editors, and so there's a little bit of magic he has to do. Don't know how. I'm sure he's going to figure something out with lots of reflection code that somehow makes the MPS team crazy, but it will work. Okay, so that was KernelF. I talked a bit more about this because I'm quite passionate about this. I built most of the language, so that's why. So the interpreter. There's two things to that. One is the interpreter framework, and then there is its use in MPS. So I guess you all know what an interpreter is, right? It's a program that implements the semantics of a language without generation. So you don't generate something else, but you have a program that essentially walks the AST and does stuff. And the framework where specifically Nico has built while he was still at Amos is an interpreter for functional languages. So you can imagine it as a .eval method on the language concepts. It's implemented differently for various reasons. The execution domain is Java. So you write base language code to define the semantics of your own language. There are other ways of building interpreters with a more transformation-based approach. We're experimenting with this, but we haven't done that yet. It's a very compact notation for interpreter definition. I'm going to show something in a moment. And it also respects language modularity. So if you have a language extension which comes with its own interpreter, then the framework collects everything that's relevant in your model and runs that in the way you would expect. So the way you define an interpreter is that you give it a name and a category. I think nobody's ever used a category different from that one. And then you say which languages, or for which languages do you want to define the interpreter? In other words, this has to make the concept definitions visible, right? And then you define evaluators. And so an evaluator always says, here is the language concept of your language, then here is a type guard, right, optionally, like for plus, for example, you interpret differently if two arguments are strings versus if they are numbers, right? In one case you concatenate, otherwise you add. and then you write Java code on the right side that performs the actual implementation. And there are shortcuts for various things. For example, this hash thingy invokes the interpreter recursively. So most functional interpreters are essentially a recursive call of that thing here. And that's a very short notation. Also, what it also does, it respects the type mappings you specify here. So if you say, for example, the number type of your DSL is implemented as a big integer in your implementation domain, and you specify that a particular child of your node has, for example, number type, DSL level number type, then if you call the hash on that thing, it is automatically typed to be big integer. So you get rid of all the typecasts here, which really makes things much more compact, and it's really useful. And so there's support for a stacked environment as you would have it in interpreters. So it's actually really nice for functional languages. It's except for the potential criticism that you don't want to use an imperative language on the right side, right? You could argue that you shouldn't do that, but if you accept that, then you can't get much more compact than what this thing does, and it works really well. It's not very fast, but because of the way we use these interpreters, mostly for running tests and interactive simulations directly in the IDE, it doesn't matter. There is no need for high performance optimizations. Yeah. And of course, you can then use it to, for example, take test cases and run them directly in the IDE. By the way, if somebody knows how to reduce the brightness of the beamer somehow, it would probably be useful, because there's actually a green background. Yeah, just the color settings of the projector. You know, I mean, okay, maybe, yeah. So anyway, you can write a test case, press Control-Shift-Enter, and run it directly. You can also, we have built these various ways of inspecting executions of programs. For example, here you can see that this, isn't there a remote control for the projector? Okay, well then that's maybe not screw it up. Yeah, okay. Nico, we just talked about the interpreter. Yes, in more detail. Okay, I just mentioned that it exists and gave one screenshot, and you can do the details. I also blamed you that when it doesn't work, so I didn't do that. So here, for example, you can attach these what we call value inspectors to expressions, and then you can see the values of these variables or expressions as the program executes, as a way of inspecting the behavior. Or you can even use what we call the tracer, which Sergey started at Workday, right? Where is he? Yes. And we then built on top of, where the execution of a functional program is represented as a tree, and you can also overlay the complete values over the program. So on the one hand, this is infrastructure that comes with KernelF. On the other hand, it illustrates the usefulness of having an interpreter directly in the IDE, because it brings your programs alive. And in several projects, we noted that the fact that you now have a DSL to describe stuff is all fine. Some computer science guys told you that this is somehow necessary in your domain, blah, blah, right? But if you can run these programs and execute tests and play with things and run simulators, this is where domain experts really, get it. And so that's why an interpreter used in that way is really helpful. Oh yeah, and we're about to kick off a DSL for specifying imperative interpreters, in a way where we define the step size you can build like real stepping debuggers. We've had several discussions at Amos that went from let's build a pragmatic debugger DSL to how can we formally specify the semantics and automatically generate generators from interpreters using partial evaluation. And perhaps we shouldn't, because it takes us 10 years, right? So we'll see. But there is things going on. If you're interested in joining this, let me know. Okay, solver. As I said, solver. Who knows what an SMT solver is? Okay, that's more than I thought. I didn't until a few years ago. Basically, it's a program that you can feed expressions and it tells you whether they can be solved or not. Whereas solving means you have a bunch of variables in the expressions and it tries to assign values. If it can, good. If it can't, your model is inconsistent, right? And so this can be used for all kinds of interesting things. Fundamentally, it's very simple. It's like in school, right? You did these equation systems and then you try to find assignments of variables so that everything works. Solvers can do this for millions of equations and tens of thousands of free variables within seconds. So you can, at least potentially, map your complete program to a bunch of expressions, send them to the solver, and get back something which you then have to reinterpret as meaningful error messages in your program, which is not so simple. Yeah, what we use it for is right now, for example, to check consistency and completeness of decision tables, where, for example, a table is only correct if all cases are covered, right? If there's no unhandled cases, and if each set of input values leads to exactly one solution, right? It's overlap-free. The problem is, well, this is basically simple, right? To ask a solver for that is simple. You essentially send them this. Dan can explain what this means. Point is, the complexity comes from somewhere else, because let's say you use this speed variable here, or value here, right? This comes from somewhere. It's a function parameter, or it's something that is used elsewhere in the program, and from this elsewhere, the set of possible values is already reduced. So essentially, in order to make this decision, if this is complete or not, you have to essentially look at the whole program, or at least at those parts which influence the possible sets of values of speed at the point where you use this variable, and then make the decision, right? For example, this one has overlap, because these two are overlapping, right? So that's always a mistake. But let's say speed had a type that has a range between 0 and 100. And you only checked for speed less or equal than 100. Then if you don't know about the range restriction, it's incomplete, because greater than 100 isn't checked. If you know the range restriction, the program is correct. And now a range restriction in the simplest case is directly associated with the type. Then it's easy. But the range restriction can happen because this thing is embedded inside an if, which says speed is lower than 100. And so that's why you have to essentially look at the whole program to make this decision. And that's where the complexity comes from, and that's where it takes beyond a little bit longer than we thought, because it wasn't clear to us in the beginning that that problem existed. Anyway, and then you get error messages, right? The ones you would expect. That part, by the way, is not open source, the solver integration. It's not. Well, management told us we have to make some money, you know, can't just hang around the JetBrains here, talk about stuff, not work. Somehow we have to make money. And they, for some reason, thought, well, yes, right, you work for Siemens. You work for a real company, you know how this works. Yes, exactly. So the way we've built this is basically that we use Z3 as the analysis backend, which is currently the fastest and most powerful solver there is. It's open source, built by Microsoft. Yes, sounds strange. And we have built an intermediate language to which you map your own DSL, and then this is handled automatically, and that part too, and then you only have to do the domain-specific lifting. Yeah, I think this has really a lot of potential. We're also not the first to do this, right? Microsoft has built various languages that are solver integrated, but having that available in DSLs is relevant. I mean, I can see several projects that we have right now where this specifically makes sense. Okay, using MPS in safety critical contexts is relevant. We did a project with a company called Voluntis, Paris. They built medical companion apps, meaning if you go through chemotherapy, you can put this app on your phone and enter various, your temperature and other like measurement values and side effects of the treatments you have. And then the app tells you, use this diet for the next few days, or make sure you measure your temperature again in the next 5 hours, or worst case, call your medical team. You should probably see a doctor, right? And so the algorithms that make these decisions are quite non-trivial, and the idea is that they should be actually specified by the people who know about what should happen, which is not software people, but doctors. The project made us question that second assumption sometimes, but okay. Anyway, so then you get these these apps, you know, look nice, and behind there is these essentially algorithms that are a mix of a state machine to kind of run the overall process and functions for and decision tables and stuff like that, to make complex decisions. Like, for example, do I have an example? I do not have an example. So, like, for example, temperature versus, I don't know, the state, like the progress of your therapy, and then the decision table calculates a risk factor. Like, at that stage, you can have that much fever, and if it's more, then you probably should call a doctor. So there are these complex, multi-variable-based decisions, and we use decision trees. Actually, I showed you this screenshot at the very beginning of decision tables and decision trees. That was from that project. By the way, Federico here, he was also involved in that project quite a bit, and Sergey. So the language is built by using KernelF at the base. We build a bunch of KernelF extensions, and then we have state machines for the overall process, testing and scenario language, and then a configuration language for various visualizations and interpreters. The execution happens essentially by generating XML from the algorithm specifications, and that XML is transported over the wire to the app. The reason why we use an interpreter even on the target device as opposed to actually generating code relates to the fact that there is a legal requirement that if you detect an error in one of these algorithms, you have to update quickly so you don't hurt patients anymore, right? And so that doesn't work with Apple's whatever how many days review. And so that's why you have to be able to, you know, update the algorithm right now, which is a really interesting thing. We had this discussion sometime somewhere this week, I forget where, because on the one hand side, in the safety critical context, you want your programs to be as specific as possible. So you don't have dead code, you don't have generic code, right? Because everything that's generic has the potential to have behaviors you don't want, in other words, have bugs. And here, of course, you can't get much more generic than an interpreter. So in terms of from a security perspective, from a safety perspective, having an interpreter is a bad design decision. On the other hand, to have safety for your patient, you have to be able to update your algorithms quickly, which conflicts with Apple's 5-day review thingy. So what do you do, right? Both safety requirements lead to, if you will, opposite design decisions. One would drive you to a generator and very specific code, and the other one drives you to the interpreter and very unspecific code. And that's interesting. So what we then did was we did a risk analysis. So, okay, maybe I should say this. The problem, of course, if you want to use and sell these apps, you have to get certification from the FDA, Food and Drug Agency or Administration. The thing here is called a software medical device, and it needs to get the stamp of approval. And so you have to prepare all kinds of paperwork, send it to the FDA, and they say, okay, you do it this way or you can't. And so as part of that, we did a risk analysis where things could go wrong in this whole stack. For example, there could be a bug in the transformation that generates the test implementation from the test specifications, or the MPS transformation engine could have a bug, or our interpreter could have a bug, right? And so we systematically looked at that and then came up with mitigations. Not going to talk about this in a lot of detail because, and that's the good news, we wrote a paper about this and submitted it to SOSIM, Software Systems Modeling Journal, and 2 days ago we got it accepted. So you can read all about this here. Also, as part of preparing the final version of this paper, I talked to Voluntis again after a while, and they said, oh, by the way, we forgot to mention this, but we got this thing pre-approved by the FDA. So there is a 2-step process. pre-submission and submission. Pre-submission is kind of a little bit more informal. You send them all your crap and they look at it and they say, yeah, it's probably going to work. So you might want to do the real submission, or here is a problem, you maybe don't want to do the submission. And they went through this pre-submission without any problems regarding the whole DSL and generation story. And this is interesting because traditionally using the whole DSL generation story in safety critical systems is not thought very possible, because you usually want to rely on proven tools, right? Proven in use, qualified tools. And of course, DSLs, which you just built, aren't. And MPS also isn't, because MPS would have to be developed as with a safety process, which means it would never have happened, right? So, because it takes too long. So, I think this is really interesting to have a FDA stamp on at least one project that uses that. I hope we can market this well. Okay. Yeah. So Inca, this is where I'm gonna play Tim Cook and ask Tamas on the stage.
It's kind of like a teaser. Food. It's on.
Well, you should exactly.
So, this is kind of a research project that we are working on, and it's also open source. And I want to say a few words about this because I think you should hear about this. So the context of Inca, you swapped my slides. The swap my slides.
This was the first one.
No.
Yes. It doesn't matter. This is all now.
No.
Yes. It is.
Okay. Yeah. Markus ruined my slides. Just deal with it. Okay. So the context of Inca is centered around program analysis, and I think you should hear about this because these program analyses are getting more and more important as your DSLs are getting more and more complicated. And so Inca comes with a DSL which is fully integrated into MPS, which you can use to develop program analysis. But what is nice about Inca is that whatever you write down in this DSL, that is immediately incrementalized out of the box. So what does it mean to incrementalize an analysis? Well, when you're working in an IDE as a software engineer and you modify the program, then you would like these analyses to update the result quickly, because otherwise the development workflow is just broken, right? It would be paused with lengthy cycles because the program analysis needs to update its results. So we solve this with incrementalization. So we actually listen to all these changes that you make in the program, and then the analysis gets updated very quickly, because we only consider the change in the subject program and we don't try to reanalyze the program again and again. And so we used Inca to develop various program analysis, for example, for base language Java, for mbeddr C, but we also used it to write program analysis for DSLs, like the state machine language extension in mbeddr. And on average, based on our previous experience, we actually see that it guarantees millisecond update time, so even for larger program changes, like duplicating a complete method, for example. But there are also smaller changes, like renaming a variable, but I just wanted to give you like an overview, what kind of changes are we talking about. This is integrated entirely into MPS, so I mentioned already the DSL, but it also comes with many debugging facilities. I hope I have screenshots about that. Cool. No, I'm gonna go in this order now. So just a quick peek into the architecture of Inca so that you can position this system, how it looks like in MPS. So on the left-hand side, there is a user, you, who modifies a program. And then this program, I mean, we are talking about MPS, so this program is represented as an AST. This is the analyzed program. Then there is an analysis developer who writes an Inca analysis code. So this can be, for example, an analysis that checks if you have an uninitialized variable in your program. Because, for example, in Java, if you would read from that variable, that would result in an R-pointer exception. So we would like to avoid that and then warn the user that this is a potential source of a problem. Then we have a compiler for Inca here, which actually emits code that this incremental evaluator can consume. In our case, I don't want to go into a lot of details, but we use incremental graph pattern matching. This is essentially, we use this graph pattern matching. You can imagine it as a regular expression on a string, where we use a regular expression on a graph, and this is the AST of the analyzed program. Then we have this component which is navigator. This is MPS specific because it lets the incremental evaluator know how the AST is represented. Because in our system, actually, the incremental evaluator is a third-party thing. It doesn't know anything about MPS, so it needs to be taught like how MPS represents the AST and what does it mean that the program got changed. For example, edges were inserted or nodes were removed. Then the incremental evaluator computes the analysis result, but what is more important is it incrementally updates the analysis result as the program changes. And then we use the analysis result to show errors in the IDE to the user, for example, underlining an offending code part. Here you see a screenshot of the system. Here on the upper right corner, this is an Inca program analysis code in this DSL. And you don't need to read this code. What is encoded here is this uninitialized read analysis, a super simple version of that for base language Java. On the left-hand side, you see a subject program, which we analyze with this piece of analysis. And here you see that we have underlined some part because there is an uninitialized variable there. And here in the bottom part, this one here, this is one of the debugging facilities because Inca comes with this, what we call an Inca Explorer. You can load a subject program into this Explorer and you can load an analysis into this Explorer. And then in the tree view, you see all the results of the analysis. So again, this is kind of like a teaser presentation. What you see here, these are tuples in relations. That's how Inca represents an analysis result. And whenever you change the subject program here, you can actually observe how the output changes because this tree view is automatically updated based on what comes back from Inca. Now, obviously, this debug facility may look interesting, but it's still not the way how you could integrate this into your application. Well, we solved that with a base language extension. That's what you see here on the bottom. So it's hardly readable, but essentially, we have a bunch of Java language extensions that allow you to access the analysis result from Inca. And what is also nice is that you can register something which we call a delta monitor, which gets notified when the analysis result changes, and then you get this fine-grained delta in the analysis result, like what has changed, what was removed, what was updated, and so on. And we also have a paper about this. Markus put here the link and also the barcode. And as I said, the project is entirely open source, so you can take a look at it. I'm happy to help you out if you're interested in this. And yeah, this is under active development, and this was my 5 minutes. I'm very interested to talk about this with you, and this was just my teaser, so thank you very much.
I think you have to do it like this.
Yeah, thank you.
More positions for the switch. Ah, okay, good. All right. So, 2 more things. One is the programming basics initiative. So, if you will, in some sense, this whole DSL story, to the degree these DSLs are targeted to non-programmers, to people who know about Fachlichkeit, makes a big bet, which is that we can get these kinds of people to use languages, programming languages, or DSL simplified programming languages, right? And so if we can't get people to use these things, then we don't get to spend our time building all these cool languages, which is bad. So the question is, and so when we go to customers and tell them, you know, yeah, DSLs are cool, you can do all these cool things, and then often there is this question, so yeah, but how can we get so far, the people who don't use any formal stuff, how we can get them to use a DSL? Then, yeah, we say, you know, it's going to work. We've done it before, and don't worry. And some customers don't worry, and project continues. Other customers do worry, project ends. So question is, can we do this a little bit more systematically? And so what would that mean? Well, it would mean that we somehow teach people some degree of programming or computational thinking or the notion of an expression and a type without making them actual software engineers. And so, right, we need to Chameleon Style, we need to change the color of people from domain expert to be a little bit of a programmer. I started writing a little tutorial, which is essentially programming for dummies, like the books, okay? But it has a different focus. For example, it starts by, as you see here, really teaching the basics about values and expressions, and it does that by using this spreadsheet language I've showed before. So I assume that people do know Excel, and then we start by, what actually is this thing that you put into a cell? What is a cell? A cell is something can never change, so it's not quite a variable. So we build upon that and then move them slowly out of the spreadsheet world. We, as you can see directly in chapter 2, we introduced the notion of testing, because in all the DSLs we've been building over the last years, there was a part of that language which was used to specify tests for the Fachlichkeit, right? Talk a bit about functions. We explained that functions come in all kinds of shapes, right? As soon as you have a box with parameters that gives you a new value, that's a function. Doesn't matter if its implementation is a math expression or a table, right? Stuff like that. Talking about records, collections. In this chapter here, decision and calculations, that's where the data flow language is. As an example, we have decision tables. So in contrast, so I looked a little bit at some of the other introductory programming books, and they very quickly get to, let's say, algorithms. And we don't do this here, because as a Fachlichkeitsprogrammer, you're not supposed to write, a fast sorting algorithm. You don't have to understand your own complex if-then-else nested 10 times thing, because you get a decision table for that, right? So, but you have to understand the notion of a value. You have to understand the notion of what is an instance, right? And so that's what this tries to do. And I've written these 8 chapters. For some reason, the numbering doesn't work in GitHub pages, right? So this is, of course, should be 5, 6, 7, 8. I've put a lot of examples there. Anna is currently working on building exercises so that you can interactively check whether you've understood what you've learned. I've also somehow convinced JetBrains to join with this a little bit. So I'm in discussions with Václav, so we can actually put a bunch of cloud VMs somewhere with an MPS on it that has all the code and all the exercises there, so people who can read this can press a button, they get an MPS stripped down where they can run the exercises. And so the idea is, when our customers next time ask us, so how do we get people from being not used to work structurally to being them a little bit like programmers? Well, then the answer is they can either do this themselves, or we can do a little training week. This teaches the basics, and then on top of that, we do a training on the particular DSL. Because the problem is not the DSL, right? Because the DSL has concepts that are close to the domain. It's not a big challenge to make people appreciate that this language somehow relates to what they do. But if they don't know what a value is, or something like a function, they can't use it productively. And so that's what this tries to fill. And so I encourage you to look at this and help. For example, by giving feedback, by helping with exercises or the writing. I think this is really an important initiative to kind of make this promise of DSLs like scale. Yes. Yeah. Huh. I was anxious to hear what you would say. Wow. Okay, so you thought it sucked, and they said, yeah, yes, yeah, yeah. I mean, the question is, how far do you take this, right? I started writing chapter 9, which is about mutable values and transactional memory, which, exactly, right? It might get a bit hairy, but on the other hand, KernelF has it, so I have, it's cool to write about it. But I think, yeah, but only, yes. No, but I think, so what I argue is that these two things are essentially unavoidable. You have to do that. And then I want to, the part 3 will be about managing state. And then part 4 will be about some of these very basic computer science abstractions, like things like information hiding, interfaces, things like specialization or inheritance. I mean, we have inheritance style thingies in many languages. We have something like polymorphism, not necessarily for subtyping, but for example, as laws change over time, you have different computations for the same thing, but it's polymorphically dispatched based on a time thingy. So that would be number 4. And so anyway, so that's the idea, and I really think it's useful, so please join and help. So, oh yes, that's the state. Exercises are in progress. The online tutorial is done until people complain. I mean, it's obviously not perfect, but there is stuff. The cloud VMs are in progress. So, last thing, another Tim Cook. Kolja, clicker. No.
Yes, yeah, okay. So at the end of last year, we basically started migrating some of the parts that were formerly known as the mbeddr.platform into a separate repository, also as an effort to make it more visible to other people, because it's basically it has nothing to do with the actual C part of mbeddr, right? So it's extensions to MPS itself. It's our language extensions that we have built to MPS languages like the editor language or a type system or other parts of MPS, and that we internally use to develop languages. And so at the end of last year, we started moving some of the extensions to a new repository at JetBrains. Do we have a URL here somewhere?
Yes,
yes. So it's basically on the GitHub account from JetBrains /MPS-extensions. There is a bunch of documentation I merged over the past weeks. Not about the all of the actual extensions at the moment, but how to contribute, how to port stuff from mbeddr itself over there, because we haven't ported everything. Currently, we have ported the diagrams, the tables, rich text, multi-line, some of the other notations, but there's still a bunch of stuff missing, like grammar cells and a lot of smaller extensions to MPS, like file pickers and things like that. So if you are interested to help, there's a contribution guide that pretty detailed tells what to do there and how you can help us. If you have any questions during the days, just ping me. If you have questions after the meeting, go to the Slack channel or to the repository. So on Slack, there's a channel for the MPS extensions in the JetBrains Slack instance. Just ping me there or leave a message in the channel. Or open an issue on the repository. So help is always welcome, especially if you don't want to contribute code. So documentation or things like this are very welcome to have there. So that's it.
The end. Maybe it's worth mentioning that this repository, that one of the ideas was also to do this a little bit more closely together with JetBrains. I mean, we've had these discussions forever, like, here's a cool extension, should it become part of MPS? And we always say, yeah, it should be, because then it's more visible and it helps people. And of course, from the MPS team's perspective, not trying to put words into your mouth, but you were a little bit skeptical sometimes, because it would mean that now they have to do the maintenance, right? Which, of course, they're already busy with doing the maintenance for the thing itself, MPS. And so the kind of solution we came up with was to create this common repository, which will also be like highlighted in MPS as something you might want to check out, you know, like a default plugin repository or maybe a little pop-up when you start MPS. And we're going to work on this together. And the initial like stuff we put in there is stuff from our platform. But of course, it can grow into directions that other people build, looking at the Schindlers, because, for example, of this text generation language template-based you built, for example, right? That would be a very good fit here. All right, so that's the end. I don't know, I have no clue about the time. Any questions? Okay. So you have to use your question time. Yes. No, because you don't have variables, right? You only have values, and a value gets its type once, and that value never changes, the type. But what you can do is you can have different, let's say, type depths with different ranges, and then you can use a force cast to take a value that has type bigger range to a value that has type smaller range. Of course, from a type system perspective, that won't work. It can't work. That's the whole point, that it doesn't work. But the cast allows you to get rid of the type system error, but then you have a runtime check, which verifies that the value actually fits. Yes. Yeah. So I'm answering for Tamas the one sentence I know about this. He can do the details later. In the one that's described in the paper, you can only do relational analysis that talk about relations of AST nodes. In the most current work, where he submitted the paper 2 days ago to UPSLA, right? You can do lattice-based computations on values. Yeah. And we're sponsored by Samsung. Yeah, because of the additional memory people will buy to, because of the caching. It's not an expert system in the historical sense, but yes. No. And the reason why it doesn't make any sense there is because this is must be deterministic. I mean, they have to be. This is the whole point, right? It's not a machine learning or expert system. It's really a closed, well-defined, and because of this, certifiable algorithm. It's like this discussion: how can you get a car through the safety certification if you have a self-driving algorithm based on machine learning and you can't explain how it works, right? By definition. And so, at least for what those guys do, this is not an option. What is an option is that there is also backends to this thing where the data is collected. And it is, of course, an option, and they talk about that, to use, let's say, big data and including machine learning to look at patterns and then, that kind of stuff. Yeah, but that is a different thing. That is more like what Apple does with their health kit, where they collect data and then hopefully make some conclusions about medical stuff based on huge crowds of users, right? So, more questions? All right, yes. But typically what you do is that you invoke the incremental analysis infrastructure at some point from a non-type system rule to get the error annotation, right? So in that sense, yes. Yeah. Yeah. Yes. But for example, you could invoke these things as part of the, I don't know, generator. When you want to do an optimization, you need a data flow analysis, for example, right? All right, then I think it's coffee break time, right? All right, coffee.